So I'm just going to run through a few examples here. I'm going to assume that you guys have watched the Lewis diagram videos that I've already put up. So this is going to be related directly to that pretty much. So the first example I'm going to do is NaCl, which is sodium chloride. It's also table salt, so the salt that we use like in cooking and all of that all the time. So what we do is we have Na, which is in group 1. And remember, group 1 means that it has one valence electron. So I'm going to put that there. Then we have Cl. So Cl is in group 17, or as I called it as well, group 7a, because it has 7 valence electrons. So remember that the elements, they want to have 8 electrons in their outer shell to be stable. So right now sodium has 1, so it just wants to get rid of that 1 electron. And Cl has 7, so it just wants to gain that electron. So what's going to happen is this electron is going to jump over to chlorine. I'm just going to put an X there to represent that. Now, our sodium has a full shell in between, its second shell, which was full with 8 electrons. So it's now considered stable, but it has a positive charge because it lost that 1 electron. Similarly, our chlorine now has 8 valence electrons. So it has 1 extra electron, and because electrons are negative, that means that it has 1 extra negative charge. So sodium in this case is our cation, and chlorine is our anion. I'm going to do a couple more examples just to go over this. All right, so the next example I'm going to do is magnesium oxide. So there it is there. So magnesium is in group 2, which means that it has 2 valence electrons. And oxygen is in group 16, which we called 6a. So it has 6 valence electrons. So similarly to the sodium chloride, magnesium is going to pass over both of its electrons, like so. And then we get our magnesium here. But now that it's lost 2 electrons, it's got 2 extra protons than electrons. So we're going to call that 2 plus, or plus 2. And then our oxygen, oh, my marker's running out here. Let's see if I can get that going. It has 1, 2, 3, 4, 5, 6, 7, 8. And it has gained 2 extra electrons. So it's going to have a charge of -2. So magnesium is our positive, it's our cation, and oxygen is our negative, so it's our anion. And we're going to do one more example. So the last one I'm going to talk about is, what if they don't have an equal amount that line up perfectly? So what I mean by that is, here we have magnesium fluoride. Magnesium has 2 valence electrons, and fluoride it has 7 valence electrons. So it can only accept 1 extra electron from magnesium. So let's take a look. So here we see magnesium has 2 valence electrons because it's in group 2, and our fluorine has 1, 2, 3, 4, 5, 6, 7. So it only needs 1 more valence electron. So what's going to happen is we actually need a second fluorine to come along here with its 7 valence electrons. And what's going to happen is one of them is going to go to this fluorine here, and the other one is going to go to this fluorine here. So that way magnesium is able to get rid of both of its electrons, and we have two fluorines that each gain one of the electrons. All right, I'm sorry about my marker, guys. Doing the best I can here. So our magnesium lost 2 electrons, so it has 2 extra protons, and it has a charge of +2. And then here we have our 2 fluorines that now each have 1 extra electron, which means that they each have a charge of -1. There and there. All right, sorry about the marker, guys. But if you have any questions, please let me know. Have a good one. See ya.